Question 18 is about expected value and binomial experiments. Here we have a problem on car insurance. A car insurance policy that costs $300 will pay $25,000 if the car has been stolen and not recovered. If the probability of a car being stolen is P equals 0.0002, which is a very small value, what is the expected value of the profit or loss to the insurance company for this policy? So here, whenever expected value is asked, expected value of profit or loss, always remember you need to find x and summation of summation is the final one, probability of x. This is the probability distribution. Then when you find this expected value is basically the summation of x times probability of x. That's it. Now what is this x? First, what do we know directly? We know the probability of car being stolen is 0.002, right? So what is the probability of not being stolen? It'll just be 1 minus 0.0002. Yeah, this is the thing. 1 minus this number. So if this is the probability of it being stolen, there is still 1 minus so much probability that it will not be stolen, right? So let's solve this at 0. It'll be 992. It'll be 98. Yeah. So this is the value. Now, if the car has been stolen, what is the loss for this particular policy for this company? See, they are gaining 300 from each customer. So the gaining is no matter what, the customer will have to pay 300. But if their car has been stolen, it'll be $25,000 loss minus whatever the profit they gain from them, right? So it'll be a net loss of $24,700. So if the car has been stolen, they will incur a loss of 24,700. But what about the other side? What is the gain? Gain is 300 for this particular probability. Now, when it's loss, we indicate it by minus sign. So because they're losing this money, it's a loss. Whereas gain is considered to be positive. We just sum them up. We can directly do it in the calculator since it's electronic part. You must try to get this table. And now minus 24,700. 700 multiplied by 0.002, it's 3 zeros. And then add it up with 300 times 0.99, sorry, 9998. Again, I missed it. So what's the answer? It's $295. So it's in positive. So that means they're going to make a profit or a gain of $295. So you can see if someone loses their car, yes, the company is going to incur a loss. They are going to pay a lot. But on average, the car losing thing is a very low probability. So they are always generally tending to make a profit of $295. So this is the thing. This policy is a big success for them. This is how insurance companies work. Though they pay if at all you claim the insurance, but most of the time nothing will be claimed. So they make a lot of profit in that. The next problem is also similar. It's about fundraisers. A school hosts an annual fundraiser where tickets are sold for baked goods, the values of which are indicated over here. You can see there's 4 different type of cakes and they cost so much. Suppose 100 tickets were sold for drawing for each of the 4 cakes. What is the expected value of a participant's net gain or loss if she buys a ticket for 1 dirham? So 1 dirham is 1 ticket. So there are total 100 tickets. So total money they will gain is 100 dirhams. Now, look, they are raising funds for the school. So obviously, they will make a lot of profit. They have to make profit. So, whatever they are spent, they have to gain much more than that, isn't it? So let us again make the table over here. X, P of X, this is the probability distribution table. And then we will do summation of P of X times X or X times, it's the same thing. Now, what is the profit if this particular participant wins the first prize, 5 dirham? So it'll be basically 5 dirham minus 1 because 1 is already given, right? So the net profit would be 4. What about the second one? It'll be 10 minus 1 here. It'll be 15 minus 1, 20 minus 1 because 1 dirham is only spent by the participant. So it'll be 4, 9, 14, 19. Okay, let's write the probabilities. There are 100 tickets, only one ticket is bought, so it is 1 by 100, that is 0.01. So let's write 0.01. Even over here, it's the same thing, 0.01, 0.01, 0.01. Are we missing something? What is the loss? Loss is 1 dirham. That is already given off, right? If this particular participant doesn't win anything, 1 dirham is gone. So that's minus 1. What is the probability of this happening? Now here you might be thinking, oh, it's 0.99, right? No, there are 4 prizes. See, it's not it's not 99 by 100, because there are 4 prizes. See, 1, 2, 3, 4. If you add this up, it'll be 0.04. So it'll be 96 by 100, that is 0.96. 1 minus all the sum of these, that'll be 0.96 probability. That'll be a loss. Now you just have to multiply and add them all up. Multiply x times probability of x plus plus. And over here it'll be minus. Let's take our calculators and do it. Here we just have to start with 4 times 0.01 plus 9 times 0.01 plus 14 times 0.01 plus 19 times it's times 0.01, and lastly minus, I'm not going to write plus minus, it's just minus 1 times 0.96. So what's the answer? It's negative half. That means it'll be negative 0.5 dirhams of loss. That is what you can expect. Also, you can see the probability is very, very low. Out of 100 tickets, you're just buying one ticket, and the probability is just very low that you're going to win anything. Okay, so that's the answer. We are 0.5 dollars. It should be in dirham, sorry. It's an AED. It's dirhams here. My apologies. So now the next type of questions is determine whether the experiment is binomial experiment or can be reduced to a binomial experiment. If it can be presented as binomial experiment, state the values of n, p, q. Then list all possible values of random variables. If not, explain why not. You survey 25 students to find out how many are left-handed. The random variable represented the number of left-handed students. See, this is a binomial experiment. Why? Because binomial experiment deals with two answers. Right, wrong, true, false, right-handed, left-handed. Something which will just be two distinct probability, okay? So yes, this is binomial experiment. I forgot to tell n. Now, what are the number of students? N is equal to 25 here. Now, probability of S is success and F is failure. What is the probability of success? Over here, what they want, how many are left-handed, and the random variable represents the number of left-handed students. So, it'll be a success if the student is a left-handed student, okay? And probability of failure would be student right hand. So that's it. So if it's right hand, it's failure. So that is basically P and Q, okay? N is the number of people in the study. P is the probability of success. Q is basically the probability of failure. That's the answer. Now you can see over here, yeah, the student will be the, now the sample answer is the student will be the left or right-handed. So that is the random variable. Over here, then you survey 200 people. So N is 200, and if they watch Monday Night Football, yes or no? See over here, they're asking whether they watch Monday Night Football. The answer can be the yes or no, isn't it? So if it's yes, that's probability of success. If it's no, not success. So this is it. N is equal to 2000. N is equal to 200. It's a binomial experiment. Percentage of people watching the Monday Night Football is basically probability of success, whereas probability of failure is given by 1 minus probability of success. That's it. If you know the probability of failure, you want to find probability of success, it's 1 minus P of F, the other way around. And over here, a person either watches Monday Night Football or he or she does not. That's it. Same way you can go through these. It's the same thing. Now, this one, okay, you want to just see phi appears. Only one. And if it doesn't appear, it's not going to appear. So yes, again, it's a binomial experiment. Why? Because only it should be something like S or no or phi or any other number. So yes, N is 10. And what is the probability of success here? It's basically 1 out of 6. Why 1 out of 6? Let me show you. There are 6 sides in the cube. Phi is just one possibility out of 6, right? So therefore, this is the probability of success of getting phi. Whereas phi out of 6, it will not happen. That is pi by 6. Either roll a phi or another number. Here, you toss a coin. Again, it's binomial experiment. Tossing coin has only 2 possibilities, right? Probability of success and failure is half and half. You ask 15 people how old they are. Now, this cannot be a binomial experiment. What is the age? It can be anything. It can be like 10 years, 15 years, 20 years, 70 years. It can vary a lot. So you won't have just 2 answers, isn't it? So in this case, it's not a binomial experiment. This is not binomial experiment because there are more than 2 possible outcomes, isn't it? Because age can be anything. Age can be any reasonable number. You survey 40 students to find out whether they pass their driving test. Yes, this will be a binomial experiment because it's either pass or fail. So success is whoever passed, failure is whoever did not pass. And the number of students n is 40. And over here, a person either passed the test or she didn't. The 19th one over here. Last question. You select 10 cards from the deck without replacement. Okay. The random variable represents the number of hearts. So no, this is without replacement. No, because there is lots of possibilities. It's not a binomial experiment. Since you're drawing cards without replacement, the probability changes each time because there are fewer cards. And that's basically the end of the question 18.